Good morning, one and all. Myself, Vaidehi, working as Assistant Professor in EC Department from Sri Muthukumaran Institute of Technology, Mangadu. Today we are going to see a topic from the subject Electronic Devices and Circuits, and the subject code is EC3353 for second year ECE third sem students. Next, the course outcomes are: at the end of the course, the students can have the knowledge of exposure to all types of devices and circuits constructed with discrete components. And the course outcome 2 is students can be able to analyze the frequency response of small signal amplifiers. And the third outcome is students can be able to design and analyze single stage and multi-stage amplifier circuits. And the students can able to study about feedback amplifiers and oscillator principles. And the fifth outcome is students can understand the analysis and design of multivibrators. Next we are going to see the topic from the unit 1, semiconductor devices. What is meant by semiconductor? Semiconductor is nothing but a material which the conduction property lies between the conductor and insulator. That means it partially allows the flow of charge carriers or electrons. The semiconductor can be modified by increasing the number of electrons and holes, by increasing the conductivity by adding some impurities to the intrinsic material. There are two types of semiconductor materials available, that is intrinsic semiconductor and extrinsic semiconductor. Intrinsic semiconductor is nothing but it is a purest form of semiconductor. It does not contain any impurity atoms. For example, silicon and germanium are in its purest form called as intrinsic semiconductor. Here the flow of current is very low. So to increase the conductivity, the intrinsic semiconductor is added with some impurities. That type of semiconductors are called as extrinsic semiconductor. Here the conductivity is increased by adding the impurity. The process of adding impurities to pure semiconductor is called doping. Based on the doping, the extrinsic semiconductor is classified into two types. One is N-type semiconductor and another one is P-type semiconductor. In N-type semiconductors, we are adding pentavalent impurity atoms, that is atoms having 5 valence electrons are called pentavalent atoms. For example, arsenic, phosphorus, bismuth, antimony having 5 valence electrons. These kind of impurity atoms are added to the intrinsic semiconductors will behave like a N-type semiconductor. In N-type semiconductor, the electrons are majority charge carriers and holes are minority charge carriers. Here the conduction takes place due to the electrons. Here the free electrons are donated by the pentavalent impurity atoms called as donors. In P-type semiconductors, the conductivity can be increased by adding trivalent impurity atoms, that is atoms having 3 valence electrons in the outer shell. Example, boron, indium, gallium having 3 valence electrons in the outer shell. Here the free hole is accepted by the trivalent impurities called acceptors. In P-type semiconductor, the holes are the majority charge carriers and the electrons are the minority charge carriers. Here the conduction takes place due to the holes. Next we see about the what is diode. Diode is nothing but it is a semiconductor device that allows current flow in only one direction only. Here the diode is made up of two types of regions. One is P-type and another is N-type semiconductor. The PN junction diode is formed by the combination of P-type and N-type semiconductor. The formation of PN junction is called the PN junction diode. Here, in PN junction diode, there are two types of terminals. One is P region and N region. The P region is called as anode region and the N region is called as the cathode region. Here, a contact between the metal and the semiconductor is called the ohmic contact. This ohmic contact is used to connect P and N type region with electrodes. Here the diagram showing the P type and N type semiconductor. Here in the left hand side we can see the N region. In N region the electrons are the majority charge carriers. In the right hand side the P region, the holes are the majority charge carriers. When the external voltage is applied due to the recombination, in between the P and N region you can see a depletion region will be formed there. See, you can see the depletion region. When the P-type and N-type materials come into contact, the electrons from the N side diffuse into the P side and combine with the holes. This creates a depletion region around the junction where no charge carriers are present. Next, we see about the biasing of PN junction diode. When external DC voltage is applied to any electronic device is called biasing. Based on the polarity, the DC voltage externally applied to the device is classified into two types. When no voltage is applied, it is called no biasing or unbiasing. When P-type region is connected to the positive terminal and the N-type is connected to the negative terminal, this biasing is called forward biasing. In reverse biasing, the P-type region is connected to the negative terminal and the N-type material is connected to the positive terminal. Next we see about the forward biasing of PN junction. As I already told, the positive terminal is connected to the P side and the negative terminal is connected to the N side. You can see in this diagram. If the suitable positive voltage is applied between the two ends of the PN junction, it can supply free electrons and holes with extra energy they require to cross the junction as the width of the depletion layer around the PN junction is decreased. In reverse biasing, you can see the diagram. The positive terminal of the battery is connected to the N side and the negative terminal is connected to the P side. What will happen when the voltage is applied? By applying a negative voltage, results in the free charge carriers being pulled away from the junction, resulting in the depletion layer with being decreased. So, this has the effect of increasing or decreasing the effective resistance of the junction itself, allowing or blocking the flow of current through the diodes of PN junction. Next, we see about the current and voltage characteristics of a PN junction diode. There are two characteristics. One is forward characteristics and reverse characteristics. In forward characteristics, you can see initially if there is no current flows, you can see the graph, there is a minimum level of voltage will be increased. After the threshold voltage, the current flow will be increased. The threshold voltage will be differ for different types of semiconductor. For example, in the picture you can see germanium 0.3 voltage and the silicon 0.7 voltage. This means that if we use silicon material means the conduction will start after 0.7 voltage. For germanium, the conduction will start after 0.3 voltage. In the reverse characteristics, no current flows until the breakdown voltage is reached. A small reverse leakage current is observed until the breakdown. Next we see about the applications of PN junction diode. The PN junction diodes are used mainly in rectifiers. Rectifiers is nothing but it is used to convert AC to DC voltage. Example used in power supplies. Next, the diode is used in voltage regulators. The regulators are mainly used to maintain the constant voltage. Next application is light emitting diodes. It emits light when the forward bias is applied. Next application is photodiodes. It converts the light into electrical current. Next is Zener diode. Mainly the Zener diodes are used as voltage regulators because it conducts in reverse bias. I think students, you can basically understand about PN junction diode. Next we see in the next topic. Thank you.